Hello, students. So, we now know that if an inverse exists, it's unique. We know what it means, but we don't know what conditions guarantee us an inverse. Like, when do we have an inverse? So the answer is actually quite simple. We're going to have an inverse whenever the linear transformation happens to be a bijection. So that means it has to be both injective and surjective. So let's show that next. So let's do it in two proofs. I mean, I could do it in an if and only if, but let's say if t is invertible, then t is a bijection. So this just means, bijection means it's injective and surjective. So proof. Okay, so we'll assume t is invertible. So we now know that the inverse of t exists. So we want to show it's injective and we want to show it's surjective. It doesn't really matter which we show first. Let's try to show it's surjective. So what does that mean? Well, I haven't said where t goes, so let's say that t goes. Say that t goes from v to w. So we know that t is invertible, it goes somewhere, so let's say it goes from v to w. I want to show it's surjective. So I want to show, I'll write down what I want to show. I want to show for any w, little w in w, there is a v, so t of v is equal to w. And it's not hard to find out what this is because, well, t of v is going to be w when s of t of v is equal to s of w, when v is equal to s of w. So I'll just set v to be s of w, and then t of v equals t of s of w, which is equal to the identity of w, which is w. Okay, so that shows it's surjective. Now for injective, we usually, I'll say thus. I'll be nice here. Thus t is surjective. And now let's show it's injective. So suppose t of, I don't want to use w and v because they're both in v, so I'll just say suppose t of v1 is equal to t of v2. Okay, well then I can apply s to both sides since these are the same. So s of t of v1 equals s of t of v2. So I of v1 equals I of v2, and v1 is equal to v2. And this shows that t is injective. So we showed it is surjective and we showed it is injective, and then by definition that means it is a bijection. So we showed that if t is invertible, then t happens to be a bijection. So what else would we like to show? Well, we'd like to show next that if t is a bijection, then t is invertible. So we know if you're invertible, you're automatically a bijection, but we haven't shown that every bijection is invertible. Let's do that in the next video.